let's look at how we can convert the equation f of t equals 45e to the negative 0.016t into the annual growth form instead. So it's currently in the continuous growth form, and we would like to rewrite in the annual growth form. Let's make sure we understand the difference between the two. So we've had two different formulas, one for periodic growth rate and one for continuous growth rate that we've been using in previous examples. And so with our periodic growth rate, we're looking at the actual percent increase in one time unit. And so it's in that form of a times 1 plus r, where r is our growth rate to the power of x, or a times b to the x. So in the diagram that we have here, that would be an example of like our blue boxes. So it's this discrete change that if something is doubling, we go from 1 unit, doubling that to 2 units, doubling that to 4 units, doubling that to 8 units. So there are these specific time intervals where our amount doubles. A continuous growth rate instead is where we use our base of e, and we're looking for that continuous growth rate k in our exponent. So in our diagram, if you look at the green curve, you can see how these intersect at those key values. But rather than making these discrete jumps, we have a nice smooth continuous curve. So this is accounting for the effects of that continuously compounding growth. So there's a relationship between these two. So because those points are equal, we can see that there are, for our values of x, 2 to the x is actually equal to e to the 0.693x. And if you look at what's the same, these both have an exponent of x in there. But if you put it in your calculator, 2 is approximately equal to e to the 0.693. So looking at our two equations, to be able to find an equivalence between periodic and continuous growth rate, notice that they both have an a, they both have an x in the exponent. So we're looking at that part that is different, and that's where we're going to be looking for making a connection. So either 1 plus r or b will be equal to e to the k. So that's going to be our conversion factor. Either 1 plus r equals e to the k, or b equals e to the k, since 1 plus r is equal to b. Now let's come back to our problem. So let's convert the equation that's in its continuous growth form into the annual growth form. So this part here is telling us our e to the k value. So we know that e to the k will be equal to 1 plus r, or e to the k is equal to b. So plugging in what we have for e to the k, e to the negative 0.016 will be equal to 1 plus r. So if we subtract 1 from both sides, we get that r is approximately negative 0.01587. So this is telling us that a continuous growth rate of a negative 16% is about equivalent to having an annual growth rate of negative 15.87%. Or if we just wanted to see this in terms of b, we could say e to the negative 0.016 is equal to b. So putting that into our calculator, b is approximately equal to 0.984127. So our equivalent equation in annual growth form is that f of t would be equal to a. A hasn't changed, so a is still equal to 45. That represents our initial amount, times b, our 0.984127 to the power of t. So this is showing us the relationship between our continuous growth and our annual growth form. We ignore the a out in front and look at just the part that represents the growth. So in this case, we were given e to the power of k. We can set that either equal to 1 plus r or to b. R is telling us about the actual growth rate in our annual growth form, whereas b is giving us that multiplier that we need for our function.